Next, Manny Vellon is coming back to take a close look with you at the technical similarities and differences between Windows 103, Windows 2.0, and Presentation Manager. And he'll be giving you our best understanding of the market dynamics that you'll need to consider as you develop your marketing plans. We do not want you wasting your valuable development resources on markets that are inappropriate for your product, but because we lack a detailed understanding of your customer base and marketing plans, you'll need to factor that information into your decision-making process on your own.
In spite of its title, my talk will cover not just Microsoft Windows 2.0 and the Windows Presentation Manager. It'll also cover our current version of Microsoft Windows, version 1. Although my talk is primarily oriented at software developers who are familiar with Microsoft Windows, you may find it interesting just for its comparison of different features of the different versions of Windows and of the Presentation Manager. The first thing that I'd like to cover, or rather the things that I'd like to cover in my talk are, first of all, why we changed Windows. We've changed a variety of different things inside the product, and I'd like to give you our reasons for doing so. Having done that, I'd like to position the different Windows products, Windows version 2, the OS2 Presentation Manager, and future versions of the operating system. I'll then talk about the actual changes that we've made from version to version, and I'll then talk about a transition strategy for you as software developers to develop software for these upcoming operating systems. First, why did we change Windows? There's 3 different areas of Windows that have changed in going to the Presentation Manager. Our reasons for changing them differ in the 3 different areas. First of all, in the user interface, there's a variety of changes. You're probably aware now that we've switched from the tiled interface of Microsoft Windows version 1.0 to an overlapped interface in version 2.0 and in the Presentation Manager. We've also changed the keyboard interface. We've done this primarily in response to customer demand. I think since Microsoft came out with its tiled window interface in 1.0, people have been arguing with us, people have been complaining to us that they preferred the overlapped window approach that everybody else has followed. We've now implemented this overlapped window approach because you've asked for it and because some other things have occurred as well. First, when Windows was first developed, overlapped windows were just not as feasible as tiled windows. In an overlapped window system, for example, the screen is repainted very often. When you switch from one application to another application, you're very often having to switch the order of the windows on the screen. To do this, you have to repaint the screen. This is an operation that occurs very frequently. 2 years ago, when Windows was developed, the performance of the systems that were popular at the time, 8088 and 8086-based systems, was just not sufficient enough to make an overlapped window system feasible. Now, with 286 and 386-based systems and with improved graphics algorithms, overlap systems are simply more feasible than they were before. The final reason, as you may be aware, is that IBM has chosen the Presentation Manager interface with overlapped windows as the user interface of choice for SAA, the System Application Architecture. The next area that has changed in going from current versions of Windows to OS2 Presentation Manager is the API, the Application Programming Interface, the subroutines and functions that you as software developers call from the operating system or to the operating system to perform user interface actions in your software. We've changed the API, for one thing, to improve it. If you look at the API, the way that we interact with things like menu bars, the way that we resize windows, it really is a superior approach to the approach that was followed in previous versions of Microsoft Windows. Another reason why we changed it is for consistency. Microsoft Windows today, if you look at its different subsystems, its graphical library, the window manager, each one of these subsystems has a slightly different style to it, a different way of returning error values, a different way of coding parameters. We've looked very hard not only at the Presentation Manager, but at OS2 as a whole, and tried to provide a more consistent fashion. The final reason why we changed the API is simply because this is the most convenient time to do it. In moving from real mode MS-DOS to protected mode OS2, it was a given that some things like interrupt 21s to call the operating system, writing directly to display memory, would have to change. Protected mode of the 286 does not allow these things to be used inside applications. As long as you were changing your applications to deal with these protected mode requirements, it seemed that this was the best time to make any changes in the Windows API as well. The final area that has changed in the Presentation Manager is the driver layer, the device driver layer, how the graphics library, a device-independent library, interacts with specific devices. The way that the new driver interface works offers much better performance than the previous ways that it has worked. And it's also better able to take advantage of intelligent devices. Devices based on, say, PostScript, devices based on sophisticated graphics chips like the Intel 786 chip or the TI 34010 chip. The new driver interface is much better able to exploit these intelligent devices. Given that we have these different Windows products or window-like products, we've got Microsoft Windows version 1.0 today, we'll have Microsoft Windows version 2.0 this fall, and in the future we'll have the Presentation Manager. How do these different products relate to each other? Let's consider the evolution of Microsoft Windows. From the current version of Microsoft Windows, version 1.04, the next step is version 2.0. My diagram shows this as a small step because really the only thing that happens is the user interface changes. There's some things that if you want, you can take advantage of as software developers. Things related to the keyboard interface, for example. They're capabilities that you might want to exploit. You don't have to exploit. I think in the previous talks you've in fact seen demonstrations of applications written for 1.0 running under version 2.0 of Microsoft Windows. This is a very small step from your perspective, from the API perspective, but from the user interface perspective, it's a relatively large step. It's a step to the new user interface. Beyond Windows 2.0, there's OS2 with the Presentation Manager. This is a much more significant step. We're moving to protected mode. We've got the new API, and there's the new driver interface. I'll talk about these changes in more detail. Suffice to say, though, that that's a much more significant step for you as software developers. In the long term, where we're headed is for a 386 version of OS2, or version of OS2 that's able to exploit the capabilities of 386-based systems. Things like exploiting the large linear address space, the virtual 86 mode. We believe that this is where the software and hardware industry is heading, that 386-based machines will be the next stable platform for the future. Let me show the same information in a slightly different form to communicate a different point. Here are the different Windows products with a timeline. The key point in this slide is that none of these products, except for Microsoft version 1.0, Microsoft Windows version 1.0, disappears. We expect that Windows 2.0 and that OS2 will continue to survive, that they will coexist. In spite of my arrowhead being missing there on my slide, we expect that Windows 2.0 will be a viable development environment for the next several years. We expect to see that MS-DOS and real mode machines will continue to coexist even while OS2 is still ramping up, becoming popular on 286 and 386-based machines. Given that we expect to have all these different versions of the operating system and of Microsoft Windows around, how will we position these different products? Well, one natural way to position them is simply based on the real versus protected mode nature of the different environments. Microsoft Windows is based on MS-DOS. It's a real mode product. It can run on all the different machines. OS2 requires 286 or 386-based processors. Because of this distinction, there's some corollaries, some other positioning factors. The installed base is primarily 8088 and 8086 class machines. The ratio is something like 9 to 1. Thus, the installed base will continue to be primarily MS-DOS based and Microsoft Windows based. New products, on the other hand, will likely be 286 and 386 based machines and will be targets for the OS2 operating system. Naturally, this also translates into a low-end versus high-end distinction. The 286 and 386 class machines will likely be more expensive products than the 8086 and 8088 class machines. Thus, MS-DOS will address the low end, the home and educational environments, whereas OS2 will be more for businesses. The key point, again, is that we expect Microsoft Windows version 2.0 and OS2 to coexist. OS2 will not obsolete Microsoft Windows. To review what I've talked about, I've explained why we changed Windows, describing our reasons in terms of the different areas, the user interface, the API, and the driver layer. I've talked about how we intend to position the products, primarily on this real versus protected mode, this high versus low-end positioning. And I've talked about how Windows 2.0 and OS2 will coexist in the future. Let me talk now about the specific areas where the products differ. Let me start by talking about functionality. What new capabilities are there in OS2? Let me start, however, in moving from the current version of Windows, Windows 1.04, to the new version of Windows, Windows 2.0. There's several different capabilities that are new with the 2.0 version of Microsoft Windows. First is support for expanded memory boards. Windows will take advantage of expanded memory boards, either EMS or EEMS type boards, to provide faster context switching and to allow more applications to run in the system. Rather than discarding segments and having to reload them from disk, Microsoft Windows version 2.0 will keep segments in expanded memory. When you context switch from one application to another, rather than having to reload data from the disk, simply by switching banking registers around, you can quickly switch from one application to another. By trying to put as much information above the line, so to speak, in expanded memory, there's more resonant data that's available and more applications can fit in the system. Windows version 2.0 also has some device driver extensions. There is a new function, Extended Text Out, for example, that provides for much superior performance in desktop publishing products. If you're trying to do output of proportional fonts, you're trying to do WYSIWYG type interfaces, these extended device driver calls will provide you much better performance than Microsoft Windows version 1.04. There's improved support for older applications. This comes about in two ways. First of all, if you have expanded memory again, Windows will take advantage of that memory, and when you switch out of a non-Windows program back into the Windows environment, rather than discarding that code or preventing the context switch, Windows will try to swap that non-Windows program into expanded memory. There's another way that Windows supports older applications better than previous versions. That is by providing more cut and paste capabilities while you're in those non-Windows applications. If you're running an application like Lotus 123, you can press Alt-Tab, which brings you the Alt-Space, which brings you the control menu as it does inside Windows, and you will get a control menu. At the top of the screen, using character mode output, you will see a pull-down menu appear, and you can do more intelligent cut, copy, and paste operations than you could do with earlier versions of Microsoft Windows. The final area where Windows version 2.0 provides additional functionality is in better performance. This is primarily due to things like expanded memory support and these changes that have been made at the device driver layer. It's also provided by smarter graphics algorithms and some changes in things like font file formats. Some of the changes that we've made in these areas have provided dramatic increases in in performance, especially in outputting text to the screen or in scrolling text on the screen. Operations which are real critical to providing a good interactive system with fast response time. When switching from Windows 2.0 to OS 2, there's a lot of new functionality. What I show on the screen here, what I show on the slide, are really top-level categories that imply a lot of things. OS 2 is a protected mode environment as opposed to Microsoft Windows, which is a real mode environment. OS 2, by being in protected mode, offers each application large virtual address spaces. Applications have address spaces up to 1 gigabyte. This is in comparison to Microsoft Windows, where each application is really competing with other applications for 1 megabyte. Protected mode also offers real multitasking instead of the cooperative processing that Microsoft Windows offers, where one application has to yield to another application. It also offers better protection, since each application runs in its own virtual address space. If that application crashes, it's less likely to destroy other applications in the system, less likely to destroy the operating system itself. These are all capabilities that are delivered by running in protected mode. There's an improved graphics library that comes with OS 2. The graphics library is called GPI, the Graphical Programming Interface, instead of GDI, the Microsoft Windows graphics library. As John Butler's talk reviewed, there's a whole bunch of new functionality provided by this new graphics library. Because OS 2 and the Presentation Manager are a single product developed together with teams that are cooperating with each other very closely, the Presentation Manager has a much better relationship with the operating system than Microsoft Windows has with MS-DOS. For one thing, the Presentation Manager will not be this alternate environment that the user enters only when he wants to run a Presentation Manager application. The intent is that when the user turns his system on, the Presentation Manager will be the user interface for the user. The user won't get an A greater than prompt. He'll get a graphical Presentation Manager-based user shell that lets him manipulate the system. The final area where OS 2 provides additional functionality is in this graphical user shell. The user will be able to view his file system, will be able to start applications, will be able to traverse his subdirectories in a much simpler, much more powerful fashion than available either through Microsoft Windows MS-DOS Executive or through MS-DOS's A greater than prompt interface. If we look down the future to the 386 version of OS 2, in a sense I'm somewhat speculating here, but I think you can expect to see these additional capabilities in OS 2. First of all, support for some 32-bit operations, things like having large linear address spaces, things like context switching, being knowledgeable of the 32-bit registers on the 386. I think you can expect to see support for the virtual monitor capability of the 386. The 386 you might be familiar with. It can run multiple applications, each application thinking that it's running in an 8086 machine, whereas it's this virtualized mode of the 386. By supporting this virtual monitor capability of the 386, the 386 version of OS 2 offers to provide superior support for non-Presentation Manager applications. You'll be able to run things like Lotus 123 in an environment where it thinks that it's writing to display memory, but instead what's happening is that OS 2 is trapping on these writes to display memory, it's seeing what was written to display memory, and it's mapping it instead to a window that runs under the Presentation Manager in OS 2. So one of the things that the 386 version of OS 2 promises to offer is the ability to run non-Presentation Manager apps in Windows under the Presentation Manager. Finally, because of the 386's additional capabilities, the operating system will support additional functionality, things like demand paging, for example. To review, I've talked about functionality differences between the different products. I've talked about things like performance improvements, expanded memory support, in moving from the current version of Windows to the new version of Windows, version 2.0. I've talked about changes such as protected mode, the graphics library, when moving from Windows 2.0 to OS 2. Finally, I've speculated about what kinds of things the 386 version of OS 2 might offer beyond the current version of OS 2. Let me talk about user interface changes now. Once more, let me start with the current version of Microsoft Windows. When we move to version 2.0 of Microsoft Windows, the user interface changes in a variety of ways. First of all, as I've mentioned and as you've seen in the demonstrations, we're moving from the tiled model of Windows to the overlap model of Windows. We've made a variety of changes in the use of the keyboard. The use of the keyboard is a lot more flexible now. It enables you to do a lot of things that you simply weren't able to do before with version 1.0 of Microsoft Windows. For instance, within dialog boxes, you can have keyboard shortcuts that move the focus to specific fields very quickly rather than having to tab through all of the fields or to have to use the mouse to move to a particular field. The final area that we haven't talked about much is the multiple document interface. The multiple document interface is a way of controlling child windows in an application. Perhaps the easiest way to explain MDI is to consider an application, let's say a spreadsheet that works under Microsoft Windows. A spreadsheet that, in addition to having its spreadsheet rows and columns view, also in separate windows perhaps can display graphs or can display macros. Here's a spreadsheet that will have multiple windows, a main window and then child windows that contain these different views. This works fine in the current version of Microsoft Windows until you run two different instances of that spreadsheet application. What can happen then is that all these child windows, because they're all appearing on the screen at the same time in an overlap fashion, they become very hard to relate which child window belongs to which parent window. The multiple document interface is a way of controlling the displaying of your child windows so that all the child windows are clipped to the boundary of the parent window. So if you had two spreadsheets running, each one would have a main window. Its child windows would be clipped to the border of the parent. When we move from Windows 2.0 to the OS 2 Presentation Manager, the user interface changes are much more minor. It's our intent or design to keep the user interfaces of these two products as similar as possible. Again, there are some differences, primarily because OS 2 provides some functionality that's not available in Microsoft Windows. Some additional keyboard extension, things like pressing Control Escape to get to the switch list. This is a function that's not available under Microsoft Windows. It's only applicable to OS 2, and thus Control Escape works only in OS 2. The other area where the user interface is different is that the Windows 2.0 product is a bimodal product. It uses both the old keyboard methods and the new keyboard methods. You can press either Alt-Tab to move between windows or Alt-Escape. With the OS 2 Presentation Manager, the user interface works only in the new style. Only Alt-Escape works. The final area where OS 2 is different in its user interface is that it has a full function user shell that provides functionality beyond the simple MS-DOS executive that's available with Microsoft Windows. In the area of API changes, between the current version of Windows and Windows version 2.0, there are some changes, primarily changes that you only need to be aware of if you want to take advantage of them. Things like the multiple document interface. They're only relevant if they're things you want to take advantage of. You've seen our demonstrations. We've shown you Windows 1.0 applications running with Windows version 2.0. It's our intent, it's our objective to be able to run all Windows 1.0 applications under Windows 2.0. When we move from Windows 2.0 to OS 2, however, there are a variety of API differences. There is a new API, and I'd like to talk about the areas where the API differs from the current Windows API. I categorize these API changes into two groups. There's the simple changes and the more complex changes. In the simple changes, there's 4 different areas. There's function names have changed, the parameters to some functions and the data structures used by some functions have changed, the development files that you use, things like resource compiler files, they've changed. And finally, this new user shell has some impact on the API as well. I'd like to consider each of these independently. First, function names. Here are some examples of how function names have changed. getMessage in Microsoft Windows becomes WinGetMSG in the OS2 Presentation Manager. Line2 becomes GPI line. CreateDC becomes DevOpenDC. Many of these changes are just mechanical changes. They're one-to-one mappings. getMessage becomes WinGetMessage. We modified these API calls not to make your lives more complicated, but to provide more consistency. As you notice, each of the OS2 calls has a prefix, win, dev, GPI. This prefix identifies what subsystem the API call belongs to. By this simple change, providing greater consistency, we automatically change every single API call to be different than Microsoft Windows API calls, but not in a real substantial fashion. These are the kinds of changes that any word processor, any text editor can perform easily. Another class of simple change is data structure or parameter changes. For instance, the message structure, which is a very common one, in Microsoft Windows had 2 parameters. It had a word parameter and a long parameter, W param and L param. Well, in OS2, because there's more information that needs to be communicated throughout the system, and because we're trying as much as possible to anticipate what's going to be needed in the 386 version of OS2, we decided to change the message structure to contain 2 longs instead of a word and a long. So now there's lparam1 and lparam2. Now this is a pretty straightforward change, again one that you can use a text editor to effect as much as possible. There is one caveat though, and that's that very often these data structure changes can pervade, can burrow through the system. You might be passing wparam to a procedure A that passes it to procedure B that passes it to procedure C. And when you switch over to OS2, you'll have to remember to change not only your original data structure, but you'll have to propagate it through other routines as well. Naturally, the best way to avoid this is just to write your code in a way that, that these data structures don't get propagated. Another change that falls into the simple category are the development files. Things like the windows.h file is being replaced in OS2 with a different file. Many of the defines in there have changed. We've organized things differently to be more convenient. We've added some new information to these H files. You'll need to compile your software with the new H files. The resource compiler files have changed. A lot of the changes here are relatively trivial again. I think in the examples that Mel Kanner showed you, if you're familiar with Microsoft Windows, I think you'll see that there's a lot of familiarity in the way that the RC files look, but they are indeed different. Def files have changed just a little. I'm not quite sure what the changes are, to tell you the truth, but I have been told that the def files have changed. The icon, font, and bitmap files have also changed. Now, normally this would be considered a complex change, since you certainly don't want to have to go back into your icon editor and redraw all of your icons. But we are providing utilities that will let you convert your existing fonts, bitmaps, and icons and cursors to the new format. So this is really just a matter of running the utility and is not a complex change. The final area of simple changes are in interaction with this new user shell. One of the features of this new user shell, for example, is this switch list, or this task manager, for example, this list of the current applications that are running in the system. In an overlap system, in an overlap window system, it's very easy to lose applications. A window gets hidden behind another window, you forget that it's there. The user shell has a way of seeing everything that's running. You press Control Escape, the task manager comes up, you see all of the different applications that are alive. You can select the one you want and jump to it directly. Well, to be a part of that task manager list, you want to tell the user shell when your application runs, you want to tell it your real name. You don't want something like foo.exe to appear on that list. You want a more comprehensive name, word processing, spreadsheet, something along those lines. So your application, when it's initialized and when it's terminated, should interact with the user shell to provide this higher level information. So I've talked about the user interface differences between the different products, primarily going to from tiled into overlapped windows. I've talked about the keyboard differences and the minor differences between OS2 and Windows 2.0. I've also talked about the simple ways that the API has changed, the function names, the parameter differences, how development files have changed. I'd like now to talk about the other category of API changes, the conceptual changes, the more complex changes. Once more, there's a whole bunch of different things here. I'd like, first of all, to talk about them in a general fashion and then to go into more detail into each category. The first area of conceptual changes are in some new data structures that you have to worry about that you didn't have to worry about before. From John Butler's talk on graphics, you're now familiar with the fact that you need to worry about presentation spaces that you didn't have to worry about before. There's some new data structures. I'll go into them shortly. In any case, these are new elements that you didn't have to worry about in Microsoft Windows that are now a concern with the OS2 Presentation Manager. Preemptive multitasking. If you're a Microsoft Windows developer, this might have you worried. Certainly now you know that from the time you do a get message until you yield explicitly by doing a peek message or a get message, no other task is going to run in the system. Everything is stable and you need not worry about your environment changing on you. We've told you that OS2 is a preemptive system. Naturally, there's some impact on Windows applications. I'll go into those shortly. Another area where there's some conceptual changes or some changes that you'll have to think about a bit, it's not really just dialog boxes, it's also menu bars and how you interact with different controls, different windows that you might be using in your application. The final area is the graphics library. Let me talk about each of these. New data structures. One of the changes that will imply some thinking on your part when moving to the Presentation Manager is that currently in Microsoft Windows, many applications concern themselves with only one window. They have a handle to their client area. Whenever they need to draw, whenever they resize a window, they concern themselves only with that single window. In the Presentation Manager in OS2, you now have to worry about two different windows, two different window handles. There's what's called the frame window, and there's what's called the client window. The frame window, you can imagine it as the parent of all the windows that correspond to your application. The frame window contains the title bar window, the minimize and maximize icons. The menu bar is now a window. The client area is a window, but all of them are children of the frame window. So the frame window is something that you have to contend with now that in the past you didn't have to worry about. Presentation spaces, again, they relate primarily to graphics, and the John Butler talk on graphics will describe presentation spaces in more detail. You worry about them primarily if you intend to take advantage of retained graphics mode, a new capability of the graphics library that is not available with Microsoft Windows. The last area in the data structures changes are some OS2 structures. If you're using multiple threads in your application, if you're using multiple processes, if you're using pipes, queues, all of these OS2 kernel capabilities have data structures associated with them that if you want to exploit them, you have to be aware of them and make changes in your current applications to make them work with the OS2 presentation manager. Preemptive multitasking is another area where you have to consider some conceptual changes. Again, if you're a Windows programmer, you're used to this non-preemptive model where the system can't change on you except at very predictable times. Well, the good news is that OS2, in spite of being a preemptive system, has many of the same characteristics. If you have multiple applications, all of them doing a get message from the system, a win-get MSG from the system, when one application receives a message, until it comes back and asks for another message, no other applications will get messages. Thus, you can be assured that you will not get out of sequence with the system message queue. Now, if you think about that for a bit, your next question might be, well, what is preemptive about OS2 then? OS2 is still a preemptive system, and where this becomes obvious, even with presentation manager applications, is that things like our application style guide and really just being a good citizen in OS2 suggests that when you get a message, for example, that you respond within a reasonable amount of time, let's say within 5 seconds. If you're something like a spreadsheet application, you've just gotten a message from the system that says recalculate the spreadsheet. If it's going to take you 2 minutes to recalculate that spreadsheet, we don't recommend, in fact, we recommend that you not recalculate your spreadsheet while processing that message, because while you're doing that, no other window application will get any messages. The answer is, if you're in a situation like that, use multiple threads. Multiple threads in OS2 would allow you, having gotten the recalc message, to start another thread that does the recalculation while your main thread goes back and gets another message from the system. Because you've gone back and gotten another message from the system or requested it, other applications are now free to get messages and continue processing. Your recalculation thread now, that thread, since it's not blocked on a win-get message, that thread continues to execute, and it is preemptively multitasked along with any other threads in the system that are not blocked on win-get message. So, in general, presentation manager applications, you can continue to think about them the same way. You don't have to worry about things changing on you because of the preemptive nature on the system. On the other hand, if you're doing some time exhaustive things, if you're doing things like recalculations, then you might need to use multiple threads to be a good citizen in the system. Another area where some conceptual changes are implied in your software is in dialog boxes, and again, I said earlier, it's also in menu bars and in interacting with controls. In dialog boxes, the good news is that they're pretty much the same as in Microsoft Windows. They have pretty much the same controls. There's scroll bars, there's push buttons, check boxes, etc. One area where they're different is that dialog box procedures are no longer this weird thing different from regular window procedures. This is another area where Windows developers have looked at dialog box procedures and they've wondered why they're any different than a standard window procedure. Well, in OS2 they're not. They're pretty much the same. They respond to messages pretty much in the same way. It's not a very complex change, but you will have to go through your dialog box procedures and make some changes to them to work with the Windows Presentation Manager in OS2. The other area where dialog boxes differ is in how you interact with the controls in the dialog box. For instance, to put text inside an edit box, in Microsoft Windows right now there's a routine called set dialog item text. In OS2, in the presentation manager, rather than calling this API function, instead you would find the handle of that control, the window handle of that control, and you would send it a message. The message would tell it to change its text. In general, OS2 Presentation Manager is a lot more message-oriented than Microsoft Windows. And this is where menu bars also tie in. Menu bars in Microsoft Windows, they were kind of like hacked up in a way that they would work, but it wasn't a very clean solution. In OS2, menus, the menu bar, and all of the items are each different windows. They have window handles, and you communicate with them primarily through messages. So once more, if you wanted to gray an item on your message, on your menu bar, instead of calling a function to change that menu item, instead you would send the menu bar a message telling it to do so. So in general, you'll find that the presentation manager is primarily message-oriented instead of API function call-oriented. And this is an area where you'll have to make some changes in your code as well. If you like the function-oriented approach, it'd be relatively easy to write a set of help functions, much like the Microsoft Windows ones, that are functions that simply turn around and send messages. In fact, that's what Microsoft Windows itself does right now. The final area of more complex changes, I'm not going to go into in detail just because John Butler's talk on graphics covers all these same points, and that's the graphics library. GPI is different than GDI. We have made some comments to the extent that if your application is heavily graphics oriented, that your work of porting it to OS2 is more involved than if it's not. Actually, it's more involved in the sense that it's more laborious. If you have a lot of calls, you have to change all of them, and some of them aren't simple one-to-one mapping. So it's laborious, but I don't think it's actually very complicated. Graphics library is a graphics library. GPI and GDI, while looking different, GPI is certainly a superset of GDI. Everything you can do in GDI, you can do in GPI. And it's pretty straightforward to map all of your graphics functionality into the new graphics library. Only if you want to take advantage of some of the new functionality, things like retain graphics mode. Only then will you have to do some major thinking in terms of how you want to rewrite your application for OS2. So to review, I've talked about the more conceptual, the more complex API changes when going from Windows 2.0 to OS2. These are data structure changes, things like worrying about presentation spaces, things like preemptive multitasking. You might need to do multi-threaded applications if some of your functions are very time-consuming. Things like interacting with dialog boxes and interacting with your menu bar. The means for doing so is different in OS2 than it is in Microsoft Windows. Finally, the graphics library can require some more conceptual changes. Beyond the API, the final area where OS2 differs from Microsoft Windows is in its device driver interface. The way that the graphics library talks to specific device drivers for individual devices. This area of differences is primarily important to you if you're an OEM or you're a device vendor and you have some drivers for Microsoft Windows. You want to know about how you have to change them for OS2 Presentation Manager. In general, if you're an ISV just generating application software, you don't really have to concern yourself with these driver changes. In any case, the Windows Presentation Manager part of OS2, to adapt it, the drivers that you are concerned with now are just display drivers and printer drivers. There's also these keyboard mapping tables that you need to change only if you're an OEM selling in some foreign market. If you're selling OS2 machines in Europe or South America or the Far East, you'll have to change these keyboard mapping tables in addition to providing output and display drivers. The Microsoft Windows drivers, the system driver, the keyboard driver, the datacom and sound drivers all go away. In the case of the system and keyboard driver, they're no longer necessary because the presentation manager and the operating system kernel are a much better match for each other. They were developed at the same time by teams cooperating with each other very closely, and all of the functionality that we need from the operating system is provided by the OS2 kernel itself. No additional drivers are necessary. In the case of the COM driver, once more, the async datacom facilities provided by OS2 are functionally equivalent to the COM driver that was made available in Microsoft Windows. So the COM driver is not really needed for the presentation manager. Because you can have multi-threaded applications, because your applications can create separate processes that are multitasked in a time-slicing, preemptive fashion, it's easy to use these OS2 kernel capabilities. It's easy to write applications that poll devices periodically, that have guaranteed CPU time, so to speak. Things that were difficult to do with Microsoft Windows, things that prompted us to do things like write COM drivers. The sound driver, to be honest, we simply found that it wasn't of much use, even in MS-DOS with Microsoft Windows. The little speaker in the AT and IBM class machines was not capable of providing very good sound. Nobody was really using it. In OS2, being a multitask system, with the system timers being used for a variety of functions, sound was really not very useful at all, implemented the way it was in Microsoft Windows. Naturally, if there's any of you software developers that want to write a sound package that maybe works with special hardware, you're welcome to do so and to provide API functions to make that available to other software developers. The driver interface layer has changed. This is the way that the graphics library calls the specific devices. Really, what I should have done here is to provide some kind of a diagram showing you the new technique. Not having that diagram, perhaps a verbal example can help to explain this a bit. In Microsoft Windows, imagine if the application is trying to do something like fill a polygon. It's trying to do an arbitrary polygon and fill it, maybe paint it blue. The way that works right now with Microsoft Windows is that the application calls the graphics library and tells it to draw a polygon. The graphics library, if it's talking to a device that knows how to draw its own polygon, say a plotter, it simply tells the device, draw a polygon. If it's talking to a device that doesn't know how to do that operation, say something like an Epson printer, it does a simulation. It does its own polygon filling. The way that drivers tell the graphics library what capabilities they do and don't have is through a finite set of capability bits. The plotter driver, for example, can turn on a capability bit saying, I am capable of filling polygons. The Epson driver would say, I am not capable of filling drivers. The problem with this approach, the reason why we changed this approach in OS2, is that often, or at least in some very significant cases, these finite capability bits aren't enough to describe the functionality of a driver. A plotter, for example, might be able to fill polygons with 105 sides, but not with 106 sides. But the capability bits only let it answer yes or no. If the plotter were to respond, yes, I can fill the polygon, if the application tried to fill a polygon with 200 sides, the driver would fail. In OS2, this technique is different. What happens is there's a function table that's provided to the driver at initialization time. The function table has entry points in it, jump entries, jump vectors. There's about 14 entry points. Each one of these entry points corresponds to one of 14 major functions in the graphics library. When the driver is initialized, the driver can change any of the entries in that function table to point at itself. Let's consider something like the plotter driver and polygon filling. The plotter driver at initialization could say, yes, I know how to fill polygons, and it would do so by replacing the entry point in the function table that corresponded to polygon filling. All of the graphics library calls correspond to one of these 14 major entry points of a major function number from 1 to 14 and a minor function number. So the plotter driver at initialization time could replace the entry point in the function table with a pointer that pointed at its own code. When the application said that it wanted to draw a polygon, the call would be sent to the driver via the function table. Here's the difference. At this point, the driver has access to all of the parameters provided by the application. It can see how many sides there are to the polygon. If there's more than 105 sides, the driver can turn around and ask the graphics library to go ahead and perform the simulation. If it's less than 105 sides, the driver can do its own polygon filling. This new function table technique, because it lets the driver intercept virtually every call, allows the driver to perform more selective simulations, and it allows the driver to intercept virtually every single graphics call that there is in the graphics library. This latter capability, the capability to intercept function calls, is very important for intelligent devices. We found that the capability bits provided by Microsoft Windows, while very extensive and very appropriate for the class of devices that were available at the time, are now not completely sufficient to deal with things like PostScript printers and things like 34010 or Intel 786 based output devices. By intercepting specific graphics library calls, drivers for devices based on these chips can take much better advantage of hardware capabilities. The final benefit of this new technique, of this new driver interface, is improved performance. We've looked very closely at the data path from the application to the device, and we've eliminated as much as possible any copying of parameters. We've tried to make the data path from the application to the driver as short as possible. So to review, I've talked about the different drivers that are required for OS/2, and I've described this new function table-based way of calling drivers as opposed to the capability bit approach that Microsoft Windows employs. The last thing I'd like to talk about is a transition strategy for you as software developers. I've talked about how we expect all of these different versions of Microsoft Windows to coexist, how Windows 2.0 is not going to be obsoleted by OS/2. How should you address these issues? Well, our suggestion is that you develop for Microsoft Windows today. Actually, don't even wait for Microsoft Windows version 2.0. We're giving you the Windows 1.04 software development kit along with the OS/2 SDK so that you can start developing Microsoft Windows applications today. In spite of the fact that you'll have to modify these applications for the OS/2 Presentation Manager, overall, the application architecture, the message-based characteristics of Windows, those all remain in the OS/2 Presentation Manager. If you're an expert at writing Microsoft Windows software, you'll be very prepared for the Presentation Manager when it becomes available. So develop now for Microsoft Windows. When OS/2 Presentation Manager comes out, adapt your software for the Presentation Manager. We think it'll take about 10% additional effort. If it takes you a man-year to develop your Microsoft Windows application, it'll take you about 1/10 of a man-year to adapt that software to work with the OS/2 Presentation Manager. Finally, a decision that you have to make, depending on what your application is like, is whether to address both the Microsoft Windows market and the OS/2 market, or just one or the other. We expect that Windows and OS/2 will coexist for a long time, but we also expect that the applications of the future will really be applications that demand the capabilities of OS/2, that really need the multi-threaded nature, that really need the time slice multitasking, the large address space. If you're writing applications such as these that can't easily be downsized for Microsoft Windows, it may be that you just want to use Windows as an interim step preparing you for the Presentation Manager. To summarize, I've explained why we changed Windows. I've positioned the different Windows products. I've gone into detail in the different areas where the Windows products have changed, the functionality, the user interface, the API, and the driver layer. And I've given you a suggestion, a transition strategy for you to deal with the OS2 Presentation Manager and the Microsoft Windows markets.
For additional information on the topic we just covered, be sure to take a look at the written questions and answers that accompanied this video tape.